Today I will discuss about project management and network analysis next method, CPM method, critical path method. In previous class I discussed about network diagram. প্রিভিয়াস ক্লাসে আমরা দেখেছিলাম কিভাবে একটা নেটওয়ার্ক ডায়াগ্রাম তৈরি করা হয়। সেই নেটওয়ার্ক ডায়াগ্রাম তৈরি করার জন্য কি কি জিনিস লাগে আর ইনিশিয়াল কিছু ডেফিনেশন টার্মস আমরা শিখেছিলাম। আজকে ডিসকাস করব সিপিএম মেথড, ক্রিটিক্যাল পাথ মেথড। ক্রিটিক্যাল পাথ মেথড একটা এক্সাম্পল দিয়ে ফার্স্ট অফ অল আমরা এটা ডিসকাস করব। ফর এক্সাম্পল, টাস্ক এ বি সি ডি ই এফ জি এইচ অ্যান্ড আই constitute a project. The predecessor relationship are A less than D, A less than E, B less than F, D less than F, C less than G, C less than H, F less than I, and G less than I. Draw a network diagram to represent the project and find the minimum time of completion of project where time in days of each task is as follows. Also find the critical path. তাহলে এই কোশ্চেনে বলা হয়েছে টাস্ক আছে এ বি সি ডি ই এফ জি এইচ অ্যান্ড আই, যার প্রেডিসেসর রিলেশনশিপ দেওয়া আছে, টাইম ডিউরেশন দেওয়া আছে প্রতিটা টাস্কের, কোন টাস্কটা কমপ্লিট হতে কত টাইম লাগবে, কত ডেজ লাগবে দেওয়া আছে। ফার্স্ট অফ অল এখানে নেটওয়ার্ক ডায়াগ্রাম ফার্স্টে ড্র করব। নেটওয়ার্ক ডায়াগ্রাম থেকে আমরা বের করব ক্রিটিক্যাল পাথ অ্যান্ড কমপ্লিশন অফ দ্য প্রজেক্ট টাইম। এই প্রজেক্টটা কমপ্লিট হতে কতদিন লাগবে সেই টাইমটা বার করতে হবে। তাহলে প্রিভিয়াস ক্লাসে আমরা দেখেছিলাম প্রেডিসেসার রিলেশনশিপ থেকে কিভাবে আমরা প্রেডিসেসারগুলো বার করতে পারি। তাহলে এখানে টাস্ক কোরেসপন্ডিং প্রেডিসেসার and time. Tasks here A, B, C, D, E, F, G, H and I. Their corresponding predecessor. A less than D. That's mean A is the predecessor of D. A less than E. That's mean A is the predecessor of E. B less than F. That's mean B is the predecessor of F. D less than F. D is the predecessor of F. C less than G. C is the predecessor of G. C less than H. C is the predecessor of H. F less than I. F is the predecessor of I. G less than I. G also is the predecessor of I. And A, B, C, they have no predecessor, so we write blank. Their time also given 8, 10, 8, 10, 16, 17, 18, 14, 9. First of all, we draw using task and their corresponding predecessor in network diagram. So there are ABC event, there are no predecessor. So ABC start from a node A, B and C. D start from A. D start from A. E also start from A. F start from B and D. So B and D are combined. So we can combine B and D. And E start from A. From B and D start F. So F start from B and D. G start from C. G start from C. H also start from C. F and G start. I start from F and G. So F and G here combined. And so also write H. From here start I. There are no ending point of E and H. So E and H joined in this node. So we can write E. Also we can write H. This is the network diagram of our given problem. Now we find the critical path and completion time of the project. So we write the same network diagram using by number. We get the network diagram this. we get this network diagram: A, B, C, D, E, F, G, H and I. Now we numbering the nodes like 1, 2, 3, 4, 5 and 6. For critical path, first of all, this network diagram draw by using Fulkerson rule. Fulkerson rule. Now we find the critical path from the network diagram. For critical path, we find two things like earliest time starting time and latest finishing time. We find E and F, E and L. E means earliest starting time and L means latest finishing time. How to find this? First of all, for all nodes we find E and L. So we write E and L for every node. How to find? First of all, we use forward pass computation method to find E. Forward pass computation to find E. In forward pass method, for first node E1 is 0. E1 is 0. For first node 1, E is 0. Another thing, we also write the time for every activities or tasks. A have a time 80, B have a time 10, C have a time 8. So we write every time for each activity 8, B have a time 10, C have a time 8, D have a time 10, E have a time 16, F have a time 17, G 18, H 14 and I 9. So this time are given in the question. So we write the time for every activity. Now we find the E. For first node 1, E is 0. For second node 2, E will be the 0 plus their time. 0 plus 8, that is 8. So E1 is 0, E2 is 0 plus 8, that is 8. Similarly, we find E3. Here E3 means this 3, E3 means third node. Third node have two predecessor, 1 and 2. Third node have two predecessor, 1 and 2, from B activity from D activity. So we find the E3 using by maximum of the time from B node and D node, like maximum of 0 plus 10 and maximum of 0 plus 10 from B node. B is 0, E is 0, E1 is 0, B is 0. So we get maximum 0 plus 10, and from D node we get 8 plus 10. 8 plus 10. So maximum is 18. Hence the E3 is 18. How to find? Find from B activity and from D activity. Their maximum is E3. From B activity we get the time 0 plus 10, 10, and from D activity we get the time 8 plus 10, 18. So their maximum is 18. Hence E3 is 18. Now we find E4. E4 come from activity C. So E4 is 8. E4 equal to 0 plus 8, that is 8. Similarly, we can find F for E5. E5, 5 activities come from 2 activities. 5 come from F and G. So their maximum will be the E5. There are 2 nodes for E5. One is come from F, another is come from G. So the E5 is the maximum of 17, maximum of 17 plus 18, 17 plus 18 and 8 plus 18, that is 35. So we get E5 equal to 35. 17 plus 18 and 18 plus 8. So maximum is 35. So E5 is 35. Now we find the E6. E6 come from 3 event: E, I and H. Their maximum will be the E6. So E6 equal to maximum of 8 plus 16, 9 plus 35 and 14 plus 8, that is 44. So E5 will be the 44. This forward pass computation method we get E values, earliest starting time. Now we find the L values. For L values we use backward pass computation method. Backward pass computation method to find L. In this method, L6 equal to E6, that is 44. L6 equal to E6. So L6 is 44, E6 is 44, L6 also 44. Now we find L5. L5 come from one event, that is I. So L5 equal to L6 minus 9, that is L5 equal to L6 minus time duration 9, that is 44 minus 9, 35. So we get L5 equal to 35. Similarly, we find E5, L4. L4 come from two event, G and H. L4 is the minimum of L6 minus 14 and L5 minus 18. That is minimum of L6 means 44 minus 14. L5 means 35 minus 18. That is 17. So L4 is 17. L4 is 17. Now we find L3. L3 come from one event from L5. So L3 will be the L5 minus 70. 35 minus 17, that is 18. L5, L3 is 18. How to find L3? L3 equals to L5 minus their time duration of F, that is 17. 35 minus 17, that is 18. Now we find L2. L2 come from two event E and D. From E and D, their minimum will be the L2. So L2 will be L2 equal to minimum of L3 minus 10 and L6 minus 16. That is minimum of 17 minus 10 and 44 minus 16. That is 7. Sorry, L3 is 18. 18 minus 10, that is 8. So we get L2 equal to 8. Now we calculate L. L1 come from A event, B event and C event. Their minimum will be the L1. So L1 equal to minimum of L2 minus 8, L3 minus 10, L2 minus 10, L3 minus 10, L4 minus 8, that is minimum of 8 minus 8, 18 minus 10, 17 minus 10, that is 0. So L1 will be 0. In this way, forward and backward pass method, we compute L and E. For those node L and E values are same, this node join and we get the critical path from using that node. Here we see for node 1 L and E values are same. So we joined 1 and 3. There are 3 also L and E values are same. Similarly, we see they are also equal, these values. So first of all, 1 go in sequence like 1 then 2 then 3. So this line we ignore. First of all, 1 and 2 we join because E and L are same for 1 and 2 node. Now from 2 we see 3 nodes are same values. Now join 2 and 3. From 3 we see 5 node had same values. Now join 3 and 5. We see 5 and 6 node we can join because 6 node have same values. Now we join 5 and 6. Hence we get a path from 1 to 2, 2 to 3, 3 to 4, 3 to 5, 5 to 6. This path is known as critical path. How to find critical path? Where the L and E values are same. Critical path E equal to L. This is known as critical path. Here we get the critical path from 1 to 2, 2 to 3, 3 to 5, 5 to 6. That imply 1 to 2 means A event, 2 to 3 means D event, 3 to 5 means F event, and 5 to 6 means I event. So critical path is ADFI. Their duration is known as completion time. Total duration equal to duration of A, that is 8, duration of D, that is 10, duration of F 17, duration of I 9, that is 44. So total time 44 days to complete the work. So we need 44 days to complete the work. Hence, the minimum time of completion of project is 44 days. In this way, we solve the problem. Now we discuss another problem on CPM, critical path method. A project this is the activity and their corresponding times of completing each activity. First of all, construct the network. First we construct the network, compute E and L for each event. For each event, compute E and L. Number 3, find the critical path. Hence, find the critical path. To solve the problem, first of all, we write activities, and using activities and tasks make a diagram for network. So we see in the problem 1 to 2, 1 and 2, 1 and 3. So 2 and 3 start from the event 1. So we can write 1, 2 and 1, 2, 3. Then 4 start from 2, 4 start from 3. So 2 and 3, from 2 and 3 start 4. Next given 5 start from 3, 9 start from 4. 5 start from 3, 9 start from 4. Next given 6 start from 5, 7 start from 5. 6 and 7 start from 5. 6, 7 start from 5. Next given 8 start from 6 and 7. So 6 and 7 join, from there start 8. Then given 10 start from 8, 10 start from 9. So 9, from 9 and 8 start 10. This is the network diagram. Now we find E and L. So we write E and L for every node. Also put the time for each activity. 1, 2, 2, 4, 1, 2, 3, 1, 1, 1, 5, 6, 4, 8, 2, 1, 5, 7. Now we first put the value of forward pass computation for E. So first node we put 0. For 2 it will be 0 plus 4, that is 4. For 3 it will be 0 plus 1, that is 1. For 4, the 4 node come from 2 nodes, 2 and 3. It will be the maximum of 2 and 3. So from 2 we get 4 plus 1 5, from 3 we get 1 plus 1 2, that is the maximum is 5. So we put 5. For 5, node 5, it's come from node 3. So E values for 5 is 6 plus 1 7. For 6 it come from 5, so 7 plus 4 11, and for 7 it will be 7 plus 8 15. For 8 come from 6 and 7, it will be the maximum of 6 and 7. For 6 11 plus 1 12, for 7 15 plus 2 17, so maximum is 17. For 9 it will be 5 plus 5 10. For 10 it will be maximum of 9 and 8, that is 10 plus 7 17 and 17 plus 5 22, so maximum is 22. For L, backward pass method, we find L. L will be for 10 22. Same for E and L, same here. For last event E and L same. So L is 22. L8 will be 22 minus 5, that is 17. L9 will be 22 minus 7, that is 15. L4 is 15 minus 5, that is 10. L6 will be 17 minus 1, that is 16. L7 will be 17 minus 2, that is 15. L5 come from 6 and 7. So this is the minimum of 6 and 7, that is 16 minus 4, 12, and 15 minus 8, 7. So minimum is 7. L3 also come from 4 and 5. So it is the minimum of 4 and 5. From 4 we get 10 minus 1, 9. From 8 we get 7 minus 6, 1. So minimum is 1. L2 will be 10 minus 1, 9. L1 also come from 2 event 2 and 3. L1 will be 9 minus 4, 5, or minimum of 9 minus 4, 5, and 1 minus 1, 0, that is 0. So it is the complete of E and L values. Now we find the critical path. The condition of critical path where E and L values are same. So we see in one node E and L same, in 3 node E and L same. We joined 1 and 3. In 5 node E and L same, we join 3 and 5. In 7 node E and L same, we join 5 and 7. In 8 node E and L same, we join 7 and 8, and also join 8 and 10. So we get the critical path for this project is 1 to 3, 3 to 5, 5 to 7, 7 to 8, and 8 to 10. Time duration is the same as last event, that is E10, or L10, that is 22 weeks. Today